This is my great honor to be here and have opportunity to share with you with this topic, technology research, a vital element, a component of railway industrial localization. So I am coming from Rail and Modern Transport Research Group. We are under National Metal Material Technology Center, or MTech, NASA, National Science and Technology Development Agency. And today, I have only 20 minutes for talking, right? I will be on time, okay?
Do you want more?
No, actually, a little bit more, it's okay. So, and my today talk, I will give you motivation why we have to do this kind of project. And then I give you some introduction regarding to high-speed railway track system. And then I will present about technological capability enhancement of industry project. And then I will discuss regarding to technology research. And finally, I summarize my talk. So I think I should go down to stand over there because it's too high for me. Okay. So the first topic, as I mentioned, motivation. You can look that Thailand has a dream. We will construct many high-speed rail across our nation. So regarding to urgent phase, on the top, this one. Okay. There are 3 lines must be constructed. The first line is Bangkok-Nong Khai project, which distance around 600 kilometers with 11 stations. And we still have a second project regarding to 3 airport rail link with the distance around 200 kilometers. And another one is Bangkok linking to Pistonolok, and it's still pending. Based on the information, you can have a look here. It's supposed to be finished and open in 2076, right? And what happened? We got delay. And regarding to 3 airport rail link, and again, it's supposed to be open in 2029. Okay, this year, 2024, and next year, 2025. So again, we got delay. But, so we cannot wait anymore for the research. We need to prepare something for our industry because we need to bring our existing technology to be and involved in emerging market in the future. That's why we conduct this kind of activities. So I just show you example to have a look on the cost distribution. Regarding to 3 airport rail link project with a distance 220 kilometers, you can imagine that we spend a lot of money, more than 200,000 million baht. You can make, roughly rough estimation that every single kilometer we pay around 800 million baht. We pay a lot. That's our money from our tax, right? And can we harvest something from this kind of project? I think we have to do. So, and you have look here, the budget required, only civil work, and another thing in the high-speed railway project. we pay around 160,000 million baht. That's huge money. So, and you have a look here, the cost contribution. The major cost contribution coming from civil and track work, the contribution more than 70%. And the rest from M&E and purchasing vehicles, of course, from China. So, and if you look in detail regarding to civil and track work, as I mentioned, the cost contribution around 70%. 20% coming from civil work, around 60%, and the rest coming from track work, around 10%. But for technology, track work is a little bit higher than civil work. So I will show you the component. So this is example showing the track work in China, because as you know that China is major player in the high-speed railway business. In the track work, so in China, they have like China railway track system, CRTS, which are CRTS 1 slab track, CRTS 2 slab track, and CRTS 3 slab track. And they still have like CRTS double box or DB non-ballastless track. So on the track work, there is a major component or important component here we call the fastening system or fastener. For example here, the WJ8 type fastener. What is the component of this system? Have a look here. There are a large number of components consisting in this one. For example here, the metal clip, insulation block, the B, and anchor bolt. Many components must be assembled in this system. This just for the WJ7 fastener. What is different between the WJ7 and the WJ8? The component almost the same, but the difference is the configuration. You can notice that there is a shoulder of the WJ8 here, the shoulder here. So, and as I mentioned earlier, we want to bring our existing industry to be in the emerging market. And we hope that our railway business will be emerging market, right? So you can have a look here regarding to automotive industry. They have like pyramid structure. The below one is tier 2 or lower tier supplier, and tier 1 supplier. And they make the component and submit to OEM or car maker. This is the structure of our automotive industry. So, and you can have a look here. In Thailand, we have vehicle maker around 55 automotive maker. But 77, they make vehicle or car, and 18 producing motorcycle. Okay? The important thing for Thailand, you can see here, job. This industry can create more than 800,000 jobs in our country And what happens if this industry cannot go into the future? That's why we need to create another opportunity or new opportunity for those. Okay? We try our best. So, and then we have discussion with our colleague from Thai Subcon Association and TAPMA. After we see the problem that will be in the future. So we conduct the project titled Technological Capability Enhancement of Local Industry and Product Standardization Initiative in accordance with high-speed railway project requirements. And this project has been sponsored by Lanshan Mekong Corporation Special Fund Project, China. And we have 2 years to conduct this project. So, and now we are in the first year. So, and what we are going to do in the 2-year period. So, we are going to organize technical, generic technical training, and we have to organize seminar and workshop. For example, you can see from this image. So, and also we create technical expert program exchange, which means that we invite experts from China to be in Thailand, and an expert from Thailand have to visit China to learn about the high-speed railway business in China. Okay, and the important thing for this project, this one, because we are talking about industry. As Dr. Anat mentioned, testing and standard, really important. Otherwise, we cannot enter into the market anymore, right? That's why in this project, we have to draft 2 standards of the fastening system. And also, we can find opportunity how to make research after we know the gap of industry or requirement from industry side. So finally, we hope that we can create high-speed railway industry ecosystem to be in Thailand, okay? So, as I mentioned, we are dealing with industrial peoples. And I love to work with industrial people. And I think for industry, we need to make money, right? And the money should come from the product. Industry need to make the product. And the product should be accepted by user. But the problem is how we can make standard product and high quality products. Because we are talking about high-speed railway. So regarding to high quality and standard product, we need to go back to manufacturer. And currently, I think the manufacturers are facing many challenges. For example, they need to produce more green products, or they need to deal with high efficiency and cost competitiveness. So, and we believe that technology research can enable or support the local manufacturer. So we can improve the existing product, we can develop new products, or even we can do something to enhance the product's competitiveness. So, and then again, the important thing is that here we need to have railway industrial localization. Okay, so coming back to engineering topic, as I mentioned, for the high-speed railway, 5 minutes. Okay, I will be on time. Okay. In the high-speed railway, in terms of track work and infrastructure, the fastening system plays a really important role because its function, the key function of fastening system is to fasten the rail steel and slipper together tightly and to maintain the rail gauge and to ensure the stability of the rail track and also to decrease shock noise and enhance ride comfort. So, and what is the core component of the fastening system? Based on my understanding, after I talked to experts in China, we can identify that there are only 2 parts that if we can overcome, we can make the fastening system in Thailand locally. The first one here, metal clip, if we can make it. So some of you, oh no, we cannot. But I believe we can. And another thing here, gate block. If we can do this kind of thing, then we can make the entire system. Because we have rubber experts sitting over there. So, okay, we work together, no problem. And now I would like to focus on metal clip. Look, if we want to make it in Thailand locally, so I just show you here the manufacturing process. So start from raw material and then shear it. Okay, shearing, and then heat it up to appropriate temperature before forming. And then do hardening and tempering to improve the property according to the requirement of high-speed railway usage. Okay? So, and I try to make this kind of process more simple here. Start from raw material, sequential hot forming here, and heat treatment. And finally, we can obtain high-quality products. And I just put, gold star at the importance process here, sequential hot forming and heat treatment. If we can understand this process or this step of manufacturing clearly, then we can make rail clip. So, and regarding to material, raw material, I think no problem. We can import from major manufacturing country. Okay? For example, here, we can use this kind of material, EN 189, or 56 silicon 7. If you familiar with JIS standard or Japan standard, this is categorized as SUP7. Okay? So, and you can have a look here, the chemical composition. So, and we just study how to make it in Thailand. Based, as you know, we coming from MTech, Metal and Material Technology Center, we we are very keen in material. So look at the material. We just study. We can understand that this rail crypt must experience the heat treatment or time up. Okay? Okay, I will speed up. Thank you. Okay. And, okay, I forgot it. Okay, and if you look at the microstructure, you can understand that how to make it. So for this, if you want to obtain this kind of microstructure, we need to do heat treatment by quenching from temperature 860 degrees centigrade in oil to control the cooling rate. And then do tempering at this temperature for 50 degrees centigrade. And then we can get this kind of microstructure, or we call Benedict structure. Okay? So, and then now we understand the material property. And what happened? Because in the future, we need to deal with the design, not only, manufacturing. We need to deal with design. We have to understand the characteristic of the fastener, starting from installation until to be in the service. Okay? This is a video from the YouTube. This is the process to install the fastening system on the sleeper. Okay? And during service or during operation, there are many forces acting on the rail, and other force will be transferred to the fastening system. Lateral force, vertical force, and longitudinal force. Okay? So basically, there are requirements for the fastening system. For example, camping force must be not less than 10 kilonewton. We just begin. We study with normal speed train. And in the future, we step up to high-speed train. Okay? Based on EN standard, EN 13146. And the longitudinal resistance and the fourth longitudinal force should be 7 kilonewton minimum. Okay, and we take into account these requirements. Okay, and then we use computational simulation to study what should be the characteristic, particularly stress-strain distribution in the fastener. Okay? And you can see that, for example, uplift test we conduct in different scenario. Okay? Okay? And with the lift test, and during installation, the maximum stress for Mr. Stress is around this one, 1,417 megapascal. But this value is still below the yield strength of the material. So, which means that the crypt can perform properly without concern of any failure. Okay, and what happens if we conduct lifting test, uplifting test? So the state, maximum state, maximum state of around 40 megapascal was increased with respect to the state at the installation stage. So again, with this one, it's still below the yield strength. So we don't need to worry about the failure during the operation. So, and we conduct the study with longitudinal test, and we can obtain the result like this one. Okay, come back. Okay, and, okay, this one. Lateral resistance. From all information we obtain, after we conduct the test, we can ensure that this fastener system can provide safety to the railway operation. Okay? So, but don't forget the standardization. Regarding to the high-speed railway, the fastening system have to comply to this standard, EN 13146. There are many parts, okay? Start from part 1, part 2, part 3, until part 9 for different scenario of testing. So, and finally, I just want to summarize my talk. I don't want to push many texts in the slide. I try to make a simple picture. So, as I mentioned, we want to create railway industrial localization. Okay, and based on this requirement, we have to work together. And I just bring triple hierarchy model. The domestic industry needs to work with some or national agency, including university, research agency, regulation, or even standardization organization. We have to work closely. And then how to bring our component made in Thailand locally to be used in the high-speed railway project. We have to work with the pioneer industrial partner. I recommend to work with Chinese counterpart because they can talk to some consultancy or even construction company who are responsible for high-speed railway construction in Thailand. Okay, if we can work within triple hierarchy model, I think we can sustain our railway industrial ecosystem. Okay, so however, if we want to enhance our industrial capability, we have to work in the whole value chain, start from upstream, midstream, and downstream. And finally, we can create standard and approved product that can be accepted by the user. Okay, at the upstream, we're talking about HR development, basic knowledge providing, and feedstock or raw material understanding. And midstream, we're talking about product design, manufacturing process, and QC. And downstream, verification, validation, and certification. Okay, with that, I would like to thank to State Railway of Thailand for providing good advice, and Lan Chang Mekong Corporation Special Fund providing the financial support to the project. And our colleague from industrial partner, from Thai Subcon, TAPMA, and also I have to thank to China Railway Construction Corporation, who provide a good guidance how to deal with this kind of component development. And also I have to thank to Thai Industrial Standard Institute, because as I mentioned, we have to develop two standards. We have to work with them closely. Last but not least, I have to thank to our organization, MTech and NASDA, and thank to all the colleagues. They work really hard and they contribute a lot in this kind of project. Thank you so much for your kind attention.
So thank you very much, Dr. Ekkarut. So we still have a little bit time for question and answer. If you have any question, please, we are welcome your question right now. No question. Also, one question from Dr. Anand. That's good.
So actually, it's very interesting to know that MTech NASDA is going to do this research for the high-speed rail fastening system. My question is that what standards of the fastening system is to be used? Is it EN standard or the GBT standards?
Actually, firstly, we're talking about EN standard. And in the future, we have to deal with TB and GB standard. But however, we try to create our own standard in Thailand, because we cannot adopt GB or TB standard from China directly. In Thailand, TISI can adopt only ISO standard. That's why we need to conduct the research to obtain some data, and that can be used for standard drafting. But however, I will talk to you again. So because at the end, we have to submit our prototype for testing at TISTER, because as Dr. Anand mentioned, TISTER is one-stop service. TISTER can do everything regarding to testing of the railway component and railway structure. Okay.
Thank you very much. It looks like that Dr. Nat must speed up the test facility for high-speed train, because Dr. Ekkarut tried to build up some component for the high-speed train right now.